Hello Year 11. We're going to look today at treating wastewater. We're going to start, as we normally do, with a retrieval practice. So I want you to get a piece of paper and pause the video and then answer the questions and come back when you're finished. Okay, welcome back. 3 finite sources. So we've got crude oil, coal or gas, any fossil fuel, and any metal or rock. What 2 processes are carried out to obtain potable water from fresh water? Filtration to remove solids and sterilization to kill bacteria. Name 2 methods used to obtain potable water from seawater. First of all, distillation, and the second one, reverse osmosis. And 2 disadvantages of obtaining potable water from seawater. The first one is it's expensive, and the second one, it's not really designed to do in large quantities. Okay, let's have a look at our 3 success criteria. Want you to be able to state sources of sewage, explain why it needs to be treated, describe the steps needed to treat sewage, and then explain the steps needed to treat sewage before it can be made into potable water. So let's have a little look at our wastewater. The average person in the UK uses about 150 litres of water a day. Where do you think this water is used for? So you can pause the video and write down some of your ideas. Okay, so we use it for flushing the toilet, 45 litres a day. Baths and showers, we use 50 litres. Washing our clothes, 19 litres. Dishwashing, 12 litres. In the garden, we might use 11 litres. Cooking and drinking, 5 litres. And other things that you might use water for, like washing your dog or something like that. Okay, so note out of 150 litres of potable water, we only drink about 5 litres a day, and the rest of it is waste. How could we reduce this? I want you to pause the video and think of ways we could reduce maybe each of the categories. Okay, some of the ideas that you might come up with are you can actually get things to put in your toilet system that reduces the amount of water you use per flush. You can use showers instead of baths. You could do full loads of washing, only use your dishwasher when you've got a full load to put on. Garden use, you can use those big water butts rather than using tap water. And that's about it really. Cooking and drinking we can't actually reduce, but if we reduced all the other things, we could reduce the amount of waste. Okay, so what do we understand by the word sewage? Pause the video now and write down what you think sewage is. Right, sewage, we tend to think of sewage as just our human waste, but it is actually all the waste and wastewater that leaves homes and businesses through drains. So that will include wastewater from your dishwashers, washing machines, sinks, baths, showers, toilets, and also wastewater in sewage is fertilizers and pesticides from farming. Now, wastewater must be treated at sewage treatment plants to make it safe to put back into the environment, which we normally put the safe water back into the rivers or the sea, so that the rivers and the sea are not dirty. Right, we're going to just review what we've just learnt. Give 3 examples of where wastewater comes from in our houses. What is sewage? Where does sewage come from? Where does this waste go to be treated? And why must this waste be treated? So pause the video now and come back when you've answered your questions. Okay, welcome back. Let's go through them. Right, 3 examples where wastewater come from in our houses. Right, flushing the toilet, baths, showers, clothes washing, dishwashing, garden use, cooking and drinking. What is sewage? Well, sewage is all the waste that leaves homes and businesses through drains. Where does it come from? It comes from washing machines, dishwashers, sinks, baths, showers, toilets, and from farming. Where does the waste go? It goes to a water treatment centre or a sewage works. And why must it be treated? Sewage needs to be treated because it's full of chemicals from washing and farming, and it also contains bacteria from waste, and it also contains solid and liquid organic waste. Okay, so that's our first success criteria. Now we're going to look at what happens at a sewage works. So this is a sewage works, and you can see below that I've actually put a really good video of what happens at a sewage works. So I'm going to go through it, but it might be a good idea if you pause the video, copy the link, and watch the video before I go through each stage. So pause the video now. Okay, so that was quite a good video, but I'm going to go through each stage. So there are 4 main stages of wastewater treatment. The first one is called screening. Now, screening is picking out all of the massive suspended or floating solid pollutants. A pollutant is something that you don't want there. It will have several screens, coarse and fine, so the holes will be different sizes, to catch solid objects of all sizes. Wastewater cannot be treated if there are large objects in the water, and most large objects are sent to landfill sites. So it's to remove the solid objects. Okay, the next part that we have to do, the next stage, is called primary settling. And it is the physical treatment process of removing small solids before the next stage. So the water enters the tank after it's been screened, and the floatable solids, or scum, are removed from the surface by skimmers that go round. Solid sediments settle in the first circular tank, so they settle at the bottom. The large paddles rotate, pushing the solids called sludge into the centre of the tank, and the sludge then will go down through an exit pipe and will be stored for being treated later on. What's left, the watery liquid, overflows into the next tank, and this watery liquid may still contain microorganisms, so it's not been ready to be put into rivers or sea. Right, the third stage is called the biological treatment. Here we're going to put useful microorganisms, bacteria, into the liquid water, and they're going to feed on the organic solids. They're going to break them down with what we call aerobic respiration. Now, as you know from biology, aerobic respiration means with oxygen. So we also need to bubble oxygen into the tank, and you can see why it's got so frothy there. We're bubbling the oxygen through, we're adding microorganisms, and that organic matter is going to be broken down by the microorganisms who are going to thrive on it. Okay, the final treatment. The bacteria settle out to the bottom of the tank as sediment. Now, because they're so useful, we're going to recycle them back into the secondary treatment tank, the biological treatment, or we're going to pass them into a further tank where we treat the sludge. The wastewater can now be disinfected or sterilised with chlorine or ozone. It's now safe enough to be discharged back into rivers and the sea, However, if the river is a sensitive ecosystem, then the water can be filtered through a bed of sand and even sterilised by UV light rather than using chlorine, because chlorine in rivers can be a concern as it can form toxic organic compounds. So what happens to the sludge that we made in stage 2? Well, it's very useful, but we need to actually deal with it. It's organic matter, so it comes from human waste. And what we're going to do is we're going to use some of the microorganisms and we're going to have them digest the organic matter, but this time not aerobically, but anaerobically, without oxygen, at 35 to 55 degrees C. So they're going to break it down, and we're then going to allow it to dry for up to 30 days. And once it's dried, it has 2 uses. First of all, we can use it as a fertilizer because it still contains nitrates and other substances that plants need. Or it can be incinerated or burnt to make electricity. And that means that because it's a renewable source, right, we're going to have a sustainable amount of this. It's a renewable source of energy. Okay, what I want to do now is you to read these 4 statements and just write down the numbers of the statements in the order that they are done when you are treating wastewater. So pause the video now to read these sentences and then write down the 4 numbers in the correct order that you think defines the 4 stages. Okay, so the correct order is 1, 4, 2, 3. Right, let's look at some questions to review what we've done so far. What are the 4 stages of wastewater treatment? Describe what happens at the screening stage. Describe what happens at the settling stage. Describe what happens at the biological treatment stage. What is added to sterilise the water? And how is sludge made into a useful product? So pause the video now and go and answer the questions on some paper, please. Okay, let's look at the answers now. So the 4 stages of wastewater treatment are screening, settling, biological treatment and sterilisation. At the screening stage, large objects are separated from the water and these are sent to landfill. At the settling stage, scum is removed from the surface by skimmers. Solid sediments settle in the tank and the large paddles rotate and push the solid sludge to the centre of the tank. The watery liquid left overflows into the next tank. At the biological treatment stage, bacteria and oxygen are added to the liquid to feed on the organic matter, breaking them down by aerobic respiration. The water sterilised with either chlorine, ozone or UV light, and the sludge is made into a useful product by bacteria which go through a process of anaerobic respiration at 35 to 55 degrees C. This produces methane gas which can be used as an energy source, and the remaining waste can be used as a fertiliser. So hopefully you were successful in doing that. That's our second success criteria. Now we want you to be able to explain why we do each of the steps. Okay, so just to summarise, we've got screening to remove the solids, the sedimentation to remove the smaller solids and they either sink or they're taken off the top as scum. You've got aerobic respiration whereby microorganisms basically digest the organic matter with oxygen and then we can release it back into the environment after we sterilise it. The solid bits are broken down by anaerobic digestion by microbes. Then it'll either go to a fertiliser or to renewable energy. Okay, explain the necessity for screening the wastewater. Explain why the wastewater is skimmed and allowed to settle in stage 2. Explain why microorganisms and oxygen are added at stage 3. And explain the necessity for sterilising water in stage 4. So please can you pause the video and try to answer these questions. Okay, so the wastewater screened to remove large objects which would get in the way of the processes that come afterwards and block the flow of the water. The wastewater skimmed and allowed to settle in stage 2 because any solids smaller than the size of the holes in the screen in stage 1 need to be also removed before the water is treated, and these solids are organic substances which will contaminate the water. Right, in stage 3, any dissolved organic molecules need to be digested by the microorganisms. So we've removed the solids, but there might be still some things that are soluble in the water that also would make it not able to be released into the river. So air needs to be bubbled through to provide oxygen for the microorganisms, and microorganisms will carry out aerobic respiration and remove these organic molecules. Right, it has to be sterilised in order to be released into rivers, or if you were going to use it straight for potable water, we'd have to make sure that any microorganisms that remained in the water were killed. Okay, so hopefully we've been successful in that. Okay, I just wanted to touch on something that we might want to think about. All these substances are in water. We might think that there's nothing in water, but as you can see, we've got radioactive stuff, we've got arsenic, we've got pesticides, lead, calcium, we've got all sorts of substances in there. So why is it safe to drink? I want you to think about it and pause the video and come back when you've thought about it. Okay, well, it's safe to drink because they are in such minute amounts that they're not going to harm us. Right, is this following a question that science can answer? Should we add chemicals to our water? We do add chemicals to our water to make it potable. Should we add them? Is that a scientific question? Right. The answer is no, it's not a scientific question. The reason it's not a scientific question is that because everybody can have a different opinion. It's opinion. And a scientific question has to be something we can test with an experiment. Why might some people object to chemicals being added to our water? Well, some people might object because it takes away their choice. Right? Now, I know they could go and buy bottled water, but you would all have to pay for your tap water. So some people might object when things are just thrust upon them without them actually having a say in it. Okay, right, what we're going to do here is we're going to write true or false for these statements. So chlorine is added to water to improve teeth. Filtration separates solids from water. Reverse osmosis uses a mesh to separate salt from water. In wastewater, treatment air is pumped into the effluent to allow anaerobic digestion to take place. Salt is made up of sodium and fluorine ions, and distillation is used to produce potable water from seawater. I want you to pause the video now, and for those statements, just write true and false from 1 to 6. Okay, so Chlorine is added to water to improve teeth. That's false. It's fluoride ions that are added to improve teeth. Filtration separates solids from water. That's true. Reverse osmosis uses a mesh to separate salt from water. That's false because it uses a membrane. In wastewater treatment, air is pumped into the effluent to allow anaerobic digestion to take place. That's false because it is pumped in to allow aerobic respiration to take place. Salt is made of sodium and fluorine ions. Well, there's two things wrong with that. It's false because it's sodium and chloride ions. Distillation is used to produce potable water from seawater. That is true. Okay, so that's all our success criteria today. Thank you for joining me for this screencast, and I hope to see you in the next one.